Hello everyone, we are Team 1 here to present our project, which is based on paper quality control paraphrase generation. I'm Nishant Nepal. I'm here along with my teammates, Gino Choi, Vivek Casey, and Sheikh Safayat. The paper we chose is quality control paraphrase generation. The main problem statement of the paper we chose is paraphrasing. Paraphrasing is rewriting any given sentences using different words, preserving its original meaning. Like in the example shown here, you can see the same sentence, CS475 Machine Learning for NLP is a class taught by Professor Aliso of School of Computing KAIST, is paraphrased to be Aliso, a professor at KAIST School of Computing, teaches a class called CS475 Machine Learning for NLP. It's the same sentence, but it's worded differently and has a different grammatical structure. High quality paraphrases have high semantic similarity, meaning similarity in meaning. And also it has high lexical diversity, which means diversity in word choice. The goal is to generate sentences that conforms to users' desired constraints. Paraphrasing is an important task and is useful for tasks such as summarization, QA, data argumentation, etc. The motivation of our project is to test the replicability of the paper. What we found is the paper is highly replicable. The code given, although has some errors, is highly intuitive, and the experiments were easily reproducible. The second part of our project is to improve the model presented in the paper. For that, we train all three data sets, MS Coco, Wiki Answers, and Parabank 2, which were used by the author in the paper, with a single checkpoint instead of multiple individual checkpoint. And we evaluate the single model to compare it. If the metric improves, then the one trained with only one data set. We also changed the model from T5 to multilingual T5 to train and inference QCPG on Korean dataset. The dataset we chose is style KQC. We also built an end-to-end inference model for paraphrasing. At the end, we also experiment with the newly released ChatGPT. To briefly describe you about the dataset, we introduced a new dataset, style KQC, which is a style variant Korean paraphrase corpus. It is a dataset of 134K pairs of sentences divided into 100K training set, 5.K validation set, and 20K test set. The rest of the data set, MS Coco, Wiki Answers Corpus, and Parabank, are the same as presented in the replication presentation. Now we move on to the approach of training in the paper. There are two different models presented in the paper, QCPG, which is a text-to-text encoder model trained on task of control paraphrase generation. Another is quality predictor. Quality predictor model QP helps select suitable input vectors by predicting the typical quality of the paraphrase of a given sentence as.
From now on, I will briefly present about the result of our replication again. First of all, we evaluate with the mean squared error for quality predictor model. And here, left figure was the MSE of paper's QP model, and right figure was MSE of our QP model. Also, we evaluated our QCPG model with blue and the loss. Like the previous one, left figure was from the paper, and the right lower figure was for our model. The whole graph for the loss value is in the right upper graph. We can observe that the metric value of loss is a bit worse. It is due to the half number of epoch 3. Thus, we trained the model with 6 epochs this time, and because of lack of the GPU instance, we only succeed to train for Paraphrase 2 datasets. We can observe that the difference of the loss value is much smaller, which indicates that our training was similar enough to the paper. This is the overall evaluation of the QCPG model in terms of the diversities in blue. Here, we have also calculated the values for the Parabank 2 datasets with epoch 6. And it is much similar to the paper except the semantic diversity. So we can say that the model is good enough to paraphrasing in comparison to the paper. These are some examples of the prediction from our replica model. Reference sentence is the original and the prediction sentence is the paraphrased sentence. If you're interested in, please pause the video and check the result as the previous presentation.
Okay, so let me go through our improvement approach and the results we got. So firstly, we compared QCPG with quality predictor and QCPG without quality predictor model. So our hypothesis is there is no empirical importance of QP model in this experiment. So we generated two graphs. The left figure is training QCPG without QP, and the right figure is training QCPG with QP. So on the x-axis, there is offset, and on the y-axis, there is responsiveness, where responsiveness is just a norm of the difference between quality obtained at an offset O with offset 0. And on the left figure, we do not include QP, but on the right, we add the output of the QP model with the offset value. And as you can see, we observe that on the left figure, there is no variation compared to the right figure on the results. Like we can see the flat curves more often at more values of offset. So we reach to a conclusion that there is an importance of QP model because we want more diverse results with different qualities. Then our second approach was to train with Korean dataset, and we found out that the existing T5 base is not trained with Korean dataset. So we switched to multilingual T5, and then we trained it with MT5 base and then observed the results. And next we shuffled all three datasets and then trained to obtain one checkpoint and then compare the results of that checkpoint with the individually trained checkpoints. And finally, we built end-to-end inference pipeline for paraphrasing from scratch. So we wrote the code for inferencing the QP model and then integrated that with QCPC. And also, while doing the inference, we realized that the existing code gives the length of the generated paraphrases very small. So we changed some parameters in the pipeline to generate maximum of 1.5 times the length of the input sentence. Then this is the result of training Korean dataset. So these are the evaluation metrics, and this is the graph of training loss. Then over to Jino for explanation of these Korean dataset results.
Okay, our Korean model was able to give good enough paraphrase. Here, I picked 4 good examples from the generated predictions. And there also was a grammatically weird sentence like 작년 생일 파티 때 사신 케이크가 어디 케이크를 보면서죠? But we can see that the meaning is not changed a lot. Also, due to the limited tokens, there was different words between predictions and references like tablet or tablet. However, there was a lot of bad paraphrase indeed. There were grammatically broken sentences such as 어디서 사야 하는지 좀 알려줘봐 20대 어느 나라에서. And also there were sentences including the words that does not make sense like 사야지마 or 집회. We thought that the reason of this issue is twofold. First, the multilinguistic T5 is not trained on Korean only, and secondly, the size of style KQC was small.
So let me move towards another approach. So we shuffled all 3 datasets and trained to obtain one checkpoint and compared the result with the single trained checkpoint. So on the first table, you can see the results of our individually trained checkpoints. And on the bottom left, you can see the result of our combined dataset. So the first row is the result on our combined dataset, and the second row is the average of these individually trained checkpoints metric values. And you can see the difference between these two, our combined and the average, is not that much. And also the prediction is okay. Like for the reference, it was because she loved you that killed her. The prediction is he killed her because of her love for you. So this model can do inference for all 3: sentence, caption, and question. And this is the graph of the training loss and the dev loss and train loss values. And also one interesting observation is that here we just plotted the results on the validation dataset. Since the result has values on lexical diversity, synthetic diversity, and semantic diversity, which is represented by blurred score, we can see that the results are spread along the synthetic diversity in both cases, on both Parabic K2 dataset and Korean style KQC dataset. But it is interesting to see that on this Parabic dataset, the results are not that spread on the lexical dimension, which is also similar for the Korean dataset. And also for specifically for Korean dataset, you can see that results are also not much spread on this semantic dimension. So that means one future direction can be to change the evaluation metric specifically for this lexical diversity, or try some more complex dimension and get the results.
On November 13th, OpenAI released ChatGPT, and it changed the direction of the problem of paraphrase generation completely, and making much of the work in this paper about high quality paraphrase generation to be obsolete. So we decided to take a look and also show you guys some perks of paraphrase generation using ChatGPT. And after that, we will show you an interesting way of incorporating ChatGPT to our model. ChatGPT for generating paraphrases. So I'm asking ChatGPT to make 5 paraphrases of this following sentence. So as you see, is making very, very high quality of 5 paraphrase sentences. If I ask it to make more, just make more, so it's giving me 5 more paraphrases, and actually technically it can generate a lot of them. So it looks like for paraphrase generating, ChatGPT or these GPT-based models are going to be the future. First of all, we ran GPT-3 API to 1000 of our validation data for QCPG model. As you can see, GPT-3 gets much better self-blue score, and qualitatively speaking, GPT-3 results are actually much better in terms of the semantic similarities. One small advantage QCPG still has is that we can control the lexical, semantic, and syntactic values. However, one thing we have to remember that not all kind of control values are possible. And in fact, most of them are actually not. In this paper, the author suggests that to adjust the control values manually to find good results, but those search space is quite large. So we thought maybe GPT-3 can help automate this part of human supervision. One interesting thing is that GPT-3 can also tell you whether 2 sentences are paraphrases of or not. For example, here you can see 2 sentences, and GPT-3 is saying that yes, they are valid paraphrases of each other. For example, this is another negative example. So we decided to use GPT-3 to find the right control values and see whether the sentences being generated are valid or not. We ran this triple loop to get a combination of 216 output sentences from our QCPG model. For this part, we used the Hugging Face QCPG model provided by the authors. And again, a big portion of our outputs are always duplicates. For this particular case, there were 52 unique sentences. And among the 52 unique sentences, only 3 are valid paraphrases. So as you can see, the search space is huge and valid paraphrases are very hard to find. The authors also admit that. And the GPT-3 makes it very easy to find the right hyperparameters, although it takes some time, as you can see. And for example, in this example, it's a different sentence. So QCPG model generated 7 total valid paraphrases. We are seeing only 3 of them here. But yeah, before we get too excited, we need to know something about the consequences of what we are proposing. GPT-3 and ChatGPT are one of the most powerful language models to ever exist. However, sometimes they make very embarrassing mistakes and prone to silly hallucinations. Here is one such mistake I took from Twitter, from Andrewen's Twitter. However, we also ourselves saw some silly mistakes during our experimentations. So we need further experimentations and evaluation for safe deployment of these GPT-based models for any tasks, including paraphrasing. So here's the brief summary of what we have done. We have successfully replicated the given paper. We empirically verify that the importance of QP model, and we reached the accuracy described in the paper after training for 6 epochs instead of 3 epochs previously. We did some experimentation with Korean dataset. We also explored a new direction for this GPT and ChatGPT-based models to potentially replace human in the loop step. And we also empirically verify that GPT-3 generates very high-quality paraphrases. We wanted to do actually some more experimentations with GPT-3, but we couldn't do that. First of all, GPT-3 access costs some money, and secondly, OpenAI server was down for quite some time. Thank you everyone for listening to us. I want to thank everyone affiliated with this course, professors, TAs, and all my amazing classmates and teammates. Thanks everyone.